The third practice problem. Costs for a project are $12,000 per week for as long as the project lasts. So that means for every week that we are working on the project, it's going to cost us $12,000. The project manager has supplied the cost and time information shown below. Use these information to A. Determine an optimum crashing plan. B. Graph the total cost for the plan. So you can see the network diagram and AOA diagram on the right that shows all the activities. And you can see in the table the activities, the crashing potential in weeks, and the cost per week to crash. For example, for activity A, we can crash this activity by 3 weeks, and it's gonna cost us $11,000 for each week that we crash the activity. For activity B, we can crash it by 3 weeks, and the first week it's gonna cost us $3,000. The next week second and the third week is gonna cost us $12,000, and so on and so forth. So please pause here, work on this problem, try to solve it, and answer part A and part B question here. And after you're done, come back to see the solution. Let's solve the problem. The first step is to compute all the paths and their lengths and identify the critical path. We have three passes. We have path AB, CD, and EF. So let's compute the length of these passes. For path AB, the length of this path is 10 weeks plus 14, so that's 24 weeks. For path CD, the length is 13 weeks plus 6, so that's 19 weeks. For EF, the length is 15 plus 8, that's 23. So the largest length here is 24 for path AB. So that's our critical path. And also this dictates that the length of the project is 24 weeks. Next step is to rank the critical activities according to the crash costs. So we want to crash the project. We need to identify the paths that are more affordable to crash. That means they are least costly to crash. And also we are only interested in the activities on the critical path. Right now the critical path is AB. So let's take a look at the crash costs for all the activities, especially for A and B. So for activity A, the cost of crashing 1 week is 11,000. For activity B, the cost of crashing is $3,000 for the first week. We are not interested right now at other activities, C, D, E, F, because they are not on our critical path. The critical path right now is path AB. So between A, B looks like to be have a smaller cost. So we're going to select activity B for crashing, the least expensive activity. This would reduce the length of the project by 1 week, and also the critical path by 1 week. And also that means that if we are not working on a project for 1 week, we are saving $12,000, but also we are paying $3,000. So 12 minus 3,000, that's 9K. So we are saving $9,000 by crashing activity B. So the critical path is AB. We crash activity B by 1 week. So this means that the length of the activity the length of activity B is 1 week shorter, and also the length of the path AB 1 week shorter. So that means the length of the path AB is now 23. So if you look, you see that, okay, we have a 23 here and 23 here. So path EF is also a critical path. So we have two critical paths right now. So we need to keep crashing the project as long as it is possible. Let's take a look at the critical path. So we have two critical paths right now, A, B, and EF. Both have 23 weeks length. So this means that if you want to crash the project, we need to crash both paths, the path AB and path EF. So which activities on these paths should we crash? We need to take a look at the cost of crashing for these activities. So we're going to rank the activities by crashing cost on the path AB and EF. We don't care about CD right now. This is the cost table. So as you can see here, activity A is going to cost $11,000 to crash. Activity B, we already used the first week, so it's going to cost $4,000 to crash. And activity EF, activity E is going to cost $6,000 and F is going to cost $2,000. So let's rank these activities based on their cost. For path AB, B is cheaper to less costlier to crash, and for path EF, F is cheaper to crash, is less expensive to crash. So we're gonna pick F and B. If we crash F and B, then the lengths of these passes are going to be reduced by 1 week. So that would be 22 weeks, and EF would be 22 weeks as well. And it's going to cost us $2,000 for crashing F plus $4,000 for crashing activity B, and that's $6,000. And by crashing the project by 1 week, we're going to save $12,000. So that's a total of $6,000 saving. Now we need to check to see which pass is critical. So both pass A, B, and E, F are still critical here. We still keep continuing to crash the project as long as it's possible. So let's take a look at the passes that we have. We have pass AB with 22 weeks length and pass EF with 22 weeks length. So we have two critical passes. That means that to shorten the project length, to crash the project, we need to crash both A, B, and EF. Okay, so we have A and B on pass AB, and we have E and F on pass EF. Which of these should we crash? So we need to rank these based on the cost of crashing. So let's do that. Let's take a look at the table that we have. For pass AB, activity A, we see that it's going to cost $11,000 to crash this activity by 1 week. And for activity B, it's going to cost $4,000 because we already used this one the first week. So it's going to cost us $4,000 to crash activity B. For pass EF, it's going to cost $6,000 to crash E, and it's going to cost, we actually cannot use F because it can be reduced by 1 week, and we already used it before. So the only option to crash is E for pass EF. So we're going to crash B and E. B is gonna cost $4,000 and E is gonna cost $6,000. So that's $4,000 for B plus $6,000 for E, and that's $10,000. And the cost of the project per week is $12,000. So we still would save $2,000 by crashing the project. If we crash B by 1 week, the length of the path AB is going to be reduced by 1, so it's going to be 21, and the length of EF by crashing E is going to be reduced by 1 week, so it's going to be 21 as well. Now, we crash both path AB and EF, and the length of the paths are 21 now. We need to check whether we can crash these activities for the project anymore. So no further improvement is possible because we crashed actually activity B 3 times. So that means that we can no longer crash activity B. But if you want to crash activity A, that's going to cost us $11,000. And to crash activity E, it's going to cost us $6,000. $6,000 and $11,000, that's a total of $17,000, which is more than $12,000 that's going to cost us to run the project. So it's not economically beneficial or wise to do that. So that's why we have to stop here. Here is a summary of the crashing process that we did. For path AB, we crashed it by 3 weeks, and the length of it from 24 by default became 21 weeks. And we crashed path EF for 2 weeks, and the length of it from 23 by default became 21 weeks. And in the table below, you can see a summary of the process. By default, at the beginning, the length of path AB was 24, the length of path CD was 19, and the length of path EF was 23. So the critical path was path AB. We crashed activity B on path AB, and we paid $3,000, and the length of the path became 23. So we crashed the path by 1 week. In the next step, in the second crashing step, we crashed the activity B and F because we now had 2 paths that were critical, E and EF and AB both. So we had to crash both AB and EF. We picked F from path EF to crash, and we picked B from path AB to crash, and it cost us $6,000. The length of the path is the path AB from 23 became 22, and path EF from 23 became 22. On the third step, we picked B from path AB, and we picked E from path EF to crash, and it cost us $10,000. And the length of the path AB reduced by 1 week, and we became 21, and the length of the path EF reduced by 1 week and became 21. So we crashed the length of the project by 3 weeks, and it cost us $10,000 plus $6,000 plus $3,000, so that's a total of $19,000 it cost us. But it also saved us 3 multiplied by $12,000, which is $36,000. So we saved about $17,000 by crashing the project by 3 weeks.